Hello everyone, Mr. Havel here. As soon as I can get that away. Today we're going to go over the 9.4 notes, which is normal curves and the z-score. Okay, the z-score is super helpful when it doesn't land our question, I guess in this case the 70 inches, doesn't land nicely on one of our standard deviations. Okay, so if I draw up this curve here, we have heights are normally distributed with a mean of 70, right? So we got a mean of 70 and a standard deviation of 3. So what we're going to do is add 1 standard deviation, 2 standard deviations, 3 standard deviations. Then we can go the opposite way. Again, this would be 1 standard deviation, so we're just subtracting 3 to each of these. And so again, this is going to be our mean. This is plus 1 standard deviation, plus 2 standard deviations, plus 3 standard deviations. Same thing, but opposite going this way. Minus 2, minus 3. Okay. So now if I ask you a question, right? So we set up our curve and we know the percentages between each one of these, right? But then I go, well, what about if I want someone that is 75 inches tall? So the problem with this is we don't know the exact, because 75 would land somewhere right here, right? So it doesn't land nicely on one of our standard deviations, so we need to use something called the z-score. Okay, so let's try this. Our z-score here. Here's the equation for it. It's going to be whatever value you're looking for minus the mean divided by the standard deviation. Okay, so a z-score tells us how many standard deviations we are away from the mean. Okay, so for the problem above, we're going to calculate the z-score for that 75 inches. So our z-score of z of 75, okay, is going to be our value minus our mean divided by our standard deviation. And all of that information was above in the question. Okay, so that for us is going to come out to be 1.66666666 repeating. Okay, so for the z table, which we'll see below, what we'll do is round to nearest tenth. Okay, so round to the nearest tenth. So we're going to call this 1.7. Oops, 1.7. Cool. Okay, and then what we do is we can use this table that will be provided for you. You will not be making up this table, okay, which is nice. The probability that we randomly choose someone less than, that's the big one, than our given score. Okay, so if we're looking at 75, when I find it on the table, it's going to tell me the percentage or the number that is less than 75 inches tall. Okay, so it says use the table to find the probability that an adult American male is less than 75 inches. Okay, so what we do is this right here is the ones column, and this is the tenths column. So since we're looking at 1.7, we go down to 1, and so we are looking at this column right here. Okay, and then we have 0.7, which is this, sorry, I said column, but row, and then we look at this column for the 0.7. Okay, now it's really hard to see because my highlighter is thick, but where do the two intersect? And the two intersect right here on 0.9554. Okay, so the probability that it's less than 75 would equal 0.9554. As a percentage, that would be 95.54%. Again, that is less than the 75 inches tall. Cool. If we wanted more than, we would just subtract that from 100, and that would give us the more than, right? Okay, example number 2. In 2011, SAT scores had a normal distribution. It says with the mean being 518. Okay, so 518 goes right in the middle there. Standard deviation of 115. Okay, I'll cruise through this, but all we're doing is adding to this side, 115 to each one of them on this side, and then subtracting on this side. 0, 3, 288, and 173. So there's our sketch there. Now it says calculate the z-score. Sorry, I should finish reading the question. So it says here less than a 450. Okay, so in 9.3, one of our questions would have landed nicely on the standard deviation. Unfortunately, right here, we're looking at 450. Okay, so that is going to be one that doesn't land nicely on the graph. Okay, it says calculate the z-score. So our value that we're looking for minus our mean over the standard deviation. Okay, we plug that into our calculator and we get something like negative 0.591, which is approximately, again, we want to round to the 10th, so negative 0.6. It says, why do you think it's negative, right? So why do you think it's negative? In this case, it's because it's on the left side of the mean. Okay, so since it's on the left side of the mean, it's on the it's below our mean. So we're going to be less than that. So we still look at it. So I'll try to, I don't think I can, oh, maybe I can do it a little bit smaller. So this one, we are looking at, for the ones column, we're looking at negative 0. Sounds goofy, but negative 0 is right here. So that's our row. And then our column's the 0.6. So this is our column right there. Where do the two intersect? And they intersect right here at 0.2743. So the probability that it's you get a score less than a 450 on your SAT is 0.2743, or about 27%. Nice. Cool. Halfway there, folks. All right. Same idea here. It says so we have the same exact question, right? But the big thing is saying, well, what about more than 450? So the more than, what that's going to be is the probability that it's greater than a 450. There's two ways to look at it. You could look at it as 1, or if you're talking decimals, we talk 1. If you're talking percents, we're going to use 100%. Okay, so 1 or 100, depending on decimal or whatever. So we use these up here that we got in the previous example, because those are the ones that are less than. So if those are less than, to find the more than, I just find the opposite, right? So I'm going to do 1 minus 2,743, which comes out to be 0.7257. It would be the same thing if we plugged in the 27.43. That comes out to 72.57%. Either one of those are fine. This is the probability. I would say kind of go more towards this decimal one. So that would be more than. Nice. Example number 4. Nope, I lied. No, this whole thing is one problem. Okay, in 2011, we've got our SAT of 518, standard deviation of 15. That looks very similar. What is the probability that students scored between these? Okay, so we're gonna between 450 and 600. So unfortunately, we can't do this in one step, right? So we have to do multiple steps to get this. So we set up our equation. So we've got what, 518, 633, 748, 863. This is, again, just the mean plus and minus the standard deviation. So I'm just subtracting 115 for each of these. And so my question is, okay, I want between 450 and 600. right? So we know for sure because we know between these two, we know between these two, right, is 68% from last class. So we know our answer should be less than 68 because it's in between those two. So that's kind of a good hint when we finish the problem to see if we did it right. Okay, so it says first find the z-score for 600. So z for 600, what we're looking for, minus our mean, 518, over our standard deviation. That comes out to 82 over 115, which is 0.713. Okay, again, we want it as a tenth, so that's what we're going to look for. Now, that's the z-score. Kind of to stress this one, this is the z-score, not the probability. This is all we use this for is to find the probability on the table. So we have to find the z-score to use that to find the probability. Okay, now we have our z-score, so now we can find the probability with it. Okay, so we go to 0 right here, which is this column, and 0.7, which is this column. So we're following along, and bam, there's 0.7. So the probability that it's less than 600 would be, I'll write it over here so I don't run out of room, 0.7580. Nice. Okay, so it says, reminder, you already know the probability of 450, okay, which we got in the last problem, which was 2743. So now we can subtract the two of them, okay? So what that means is here's 600, and I know everything below it. And then I also know 450 and below it. So if I subtract those, get rid of those, right? And leave me with the part in between the two, okay? So the probability that it's between a 450 and a 600 is we take the probability of less than 600 minus the probability of less than 450, which is going to be 0.7580 minus 0.2743. Subtract those, and that is equal to 0.4838. Okay, and so that is probability between a 450 and a 600, which makes sense because remember we said it can't be more than 68 because it's less than that. Okay, so the probability of there. We can chat in class, why does this strategy work? It's kind of that idea right there that we are getting rid of kind of the section that we don't want, and it leaves us with a middle section there. Nice. I hope you guys enjoyed it. There's chapter 9 for you. Oh, geez.